Okie dokie. All right, so we briefly introduced the idea of iterators by showing, if you want to iterating over something is, get each thing. We do it one way if it's an array, typically. We do it another way if it's a linked structure, typically. You could do it different ways, but this is like the natural way to do each of these things, I'd say. But iterators provide a more general purpose, easy way to iterate over something regardless of the underlying container, which is nice. So there are two interfaces that we talk about. One is an interface that is how, if you implement the interface, you are defining an iterator. And the other interface is if you, an iterator is just this little, remember that little robot that would go on and then die when it was done. But then we can have a whole collection that was iterable. And an iterable collection is very simply it's an interface that means if you're implementing this interface, your collection returns an iterator, meaning there is an iterator defined for this collection. That's what we're doing. First, we talk about the iterator interface, where we go to it, and there were 4 things. 2 of them have that default keyword, which we assume means we don't really need to deal with it. But there's 2 things in that interface, next and has next, that we need to implement. Remember, they're just abstract methods. They come from an interface. So we need to implement these things. One is next, which returns the next element. And I know a lot of people can kind of get hung up on well, next is the one no, next means give me, if you're in line and you say next, whoever would come next, right? A, B, C, the little iterator, robot. If we're starting at the beginning and I say, give me the next thing, it would give me back A. If I ask it again, it would give me back B. If I ask it again, it gives me back C. After that, if I say, hey, has next, it would return false because there's nothing left. You might say, well, hold on, an array, remember, how many things are in this array? Well, there's 5, right? It's just these are empty. And it kind of depends on what do we mean here. Yeah? I'm not sure what you mean. Well, yeah, we would be asking if it had next. I was just saying if we got to here and we said has next, it would say false. If I started here, I'd be like, do you have a next? Yes. OK, give me the next. That's usually how I would do it. In fact, just like that right there. Is that what you were getting at? Perfect. So this is an iterator. This object that I get must be something that implements an iterator. However, arbitrary iterable thing.iterator. This reference variable must be referencing a class that is iterable. Because it has this iterator method. I guess it doesn't have to be, but in order for this to work right, it has to be. This thing has a method called iterator that returns an iterator. I know it can be weird, but basically, if this is like a bag, for example, the bag would be iterable, and the iterator is this thing. We are going to define an iterator. Then our bag, we're going to make iterable because it'll just return an iterator for itself. I think a concrete example, which we will see, will help make this clear. But the point is, this is my general way, a general way of iterating over something that is iterable. Right? I get the iterator. Give me my iterator. So it gives me reference to this little robot. And I say, hey, is there a next thing? Yeah? Give me the next thing. I do something with it. Is there another thing? Yeah? OK, do it again. Is there another thing? Do it again. Looking at this, is this iterating over an array or a linked structure? You don't know. There's no way to know. But that's the point, is I iterate over the thing the same way. I don't need to know if it's an array, a linked structure, or who knows what. This just gives me the next thing in order. How? I don't care. It just does. Yeah?
Wouldn't you have to know if it was iterable?
It is iterable because I can call this method. So assuming it is.
Okay. You're just assuming it's yep.
Well, it would have to be for this to work.
Okay.
Yeah.
So within
Let's have a look. So let's define an array iterator, because at the end of the day, we are defining the robot, and the robot needs to know how to iterate over the thing. The way the iterator needs to iterate over an array is different than it would over a link structure, but that's this robot. That's the iterator. When I ask the iterator, well, these questions, it will know how to interface with its underlying collection, but me, I just need to say, hey, do you have a next? Give me the next thing. And how it's built, like the iterator, will have an array iterator, but we're also going to define a linked iterator. So let's look at the array iterator. We're going to define a class, public class array iterator, generic type, implements iterator. This means that we are saying it's going to be an iterator. Anywhere Java needs an iterator, it's going to be an iterator if I implement this correctly. It's going to be an iterator. Yay. So what are we going to want? Well, I'm going to have a final size. The fact that they're final doesn't really matter here, but an int size field, an elements field, T array. It's going to be the array of things I want to iterate over, and an index. Index, I'm guessing, well, what do we say? Size is the number of elements in the collection. Elements is the array of elements to iterate over. And remember, the length of this array and the number of elements might be different, right? Like in this example, this array has length 5, but I only care about 3 things in it. So if I iterate over it, I only want these 3. I don't want to get a bunch of nulls after. An index is going to be the current index the iterator's on. So when it starts, index should be 0, then 1, then 2. The reason these are final, they don't need to be, but from a design perspective, is once these are created, they don't need to change. You might say, well, if they're constants, how come you didn't make them constant? Well, they're not really constants. They are, but they aren't, right? The spirit of like the fact that they're constant is a little bit different than the spirit of being like sales tax, you know? Default size, yeah.
Well, they're not constant because they'll change depending on the thing you're iterating over.
Exactly. Well, but like, yeah, there's new, I suppose the point is, there is a difference, right? It's like, it's a constant, but it's not. It is, but it's different, right? So they're final, they don't really need to change. And you could say, but do I really need to make them final? No, you don't. But it's kind of nice to say like, no, this is set, don't change it. It makes Java happy, everyone's happy, it's immutable, we like it. Yeah?
So you said the index would be set to 0.
Yeah.
But would that be, would it?
For an array iterator.
Yeah, okay. So would it have already done as next, or like next?
Well, we're just creating, no. We just wait. You're jumping ahead, which is good. You're trying to connect the dots, but just, I got a couple more dots to draw for you first. So public array iterator, T, this is the constructor for the array iterator. It's going to take an array of elements and a size, right? Here's the array, size would be 3. First I check here's just some basic error checking. Not really necessary, but you know, kind of nice. If size is greater than the length, you can't do that. You can't say, here's an array of length 5, there's 100 things in there. No, obviously size needs to be less than or equal to the length. Well, I guess less than. Well, size is 5 and the length is 5. Because is that right? Because if this is no, that's fine, right? Because I would loop to, presumably I would loop to less than size. Yeah, okay. It's always good to think. I scared myself for a second. Oh. Otherwise, if everything's fine, elements, elements, size, size, index 0. We start at index 0. Then we define has next. Is index less than size? There we have our answer. Is index less than size? If it is, there's a next. Otherwise, get next. Well, we've got some checking. If we ever try to do next where there isn't a next, no such element exception. Otherwise, get the return element, element at index, increment index, return the element. Notice how we increment the index. It gives me the thing, but it also has, like, next, not only does it return the thing, it's got the side effect of, like, knowing where its next thing would be, because it updates it. Yeah? And that's it. That's literally it. It's a stupid little class. It's got the thing that it makes reference, but be very careful. An iterator should never, and this is actually important. Let's go back to this. These are final. Once these are set, they should never change. Imagine my iterator would get, this is a bag, right? But I want to return an iterator for the bag. So I create this other little object that's designed to just kind of go boop, 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 down and return each element, whatever. Imagine that means this little robot has reference to this thing. If it wasn't final, it could modify the contents. Now, we shouldn't write our iterator that way, but imagine the iterator went through and it's supposed to iterate over this thing and it goes like, heh heh, it's an X now, or whatever that symbol is, right? Like it modified, oh no, the iterator should never modify the contents of this array. It's only supposed to put its finger on each thing and return, right? So that's kind of a nice thing there too. There, next returns the next element. It returns the element. The way this is written, if next is called where there's no more elements, an exception is thrown. Notice that this iterator can only go in one direction. You can only say, hey, give me the next thing, and then it updates itself in the correct direction. Once the iterator object hits the end, it doesn't reset. It just, remember, but it's happy about it. It served its purpose. It's very happy. So it got to the end. So if you're like, but what if I want to iterate again? You make a new one. You lose reference to it, and it just fades to oblivion. It's gone. There's nothing that stops us from defining, this is an iterator that says, look, it's a bag, right? And if it's an index bag or a sorted bag, there's kind of this like implicit or explicit ordering to the elements. Where do you start? The beginning, right? But there are collections out there where there really isn't an order. Like think of a set. Do things in a set have an order? By definition, no. So if you iterate over them, what order should they go? I don't know, whatever you want. So there's nothing stopping us from defining an iterator that goes in another direction. I could say like, I can make a class called like array reverse iterator, that when I call the iterator, it returns an iterator that goes from back forward. I could do that. There's nothing stopping me. I could make it go in random order until all the indices are done. I could do that. Nothing stops me from doing that. But here, there isn't like an intuitive, like, well, start at the beginning, go to the end in this context. But that's not always the case. Warning, consider that the array iterator has reference to the underlying container. Generally, iterators should not modify the collections there. We already talked about this, since side effects like this are a recipe for disaster, but they're final, so we can't anyways. And then what would a linked iterator look like? Well, here. Public class linked iterator implements iterator. It only needs one field, current. Our constructor for the linked iterator just takes reference to the head. Has next is current null. Next is, well, if it doesn't have next, whatever. Otherwise, get the recurrent, the data, update current to be the next thing, return the element. There. So this is the linked iterator. Hopefully, it's clear to you how, like, yeah, that's how I would get something and get ready for the next thing with an array iterator. And hopefully it's also clear how this is how I would get the thing and get ready for the next thing in a linked iterator. They're both doing the same function, but they're doing it in a way based on their underlying respective containers. But at the end of the day, in the same way that I used a stack or a queue, where I didn't care if I had a linked stack or an array stack, a linked queue or an array queue. I didn't care. Push, pop, in queue, dequeue, it worked. It worked. I didn't care. I didn't want to care about the underlying implementation. Obviously, we built it, so we do, but the spirit of it is we don't care. Same idea here. When I use this iterator, I say, hey, do you have another thing? Give it to me. Do you have another thing? Give it to me. I don't care if it's a linked or an array or whatever. As long as I can ask, do you have another thing? Give it to me. I'm happy. And that's what we want, because now I have that general way of iterating over something. Nope. There. You get the iterator, you have another thing, give it to me. Have another thing, give it to me. With this now, again, point is, you do not know if this is a linked iterator or an array iterator. You don't know, but it doesn't matter. I iterate over the collection, I get the elements in order regardless. Yeah?
So for that code there, when you say dot next, it would reference the first time you do it, it would reference the first.
Yeah. Remember, it's like, this is the line at Starbucks, and I'm working at Starbucks, and I say, next.
Yeah.
Yeah.
But I'm just a little confused when you said, in the construction, you set the initial to 0 already.
Yeah.
So wouldn't that reference it before, when it's first created?
Look at the order of the array one. When the array index 0, so it's like, that index is here, right? Then I say, hey, give me the next thing. Okay, get the element from 0, A, increment it, so it would be the next thing, then return the thing at the beginning. So it always starts with give me the first thing. Don't get too, every year everyone's like, people seem to get hung up on the word next. And the fact that people are getting hung up on the word next tells you that maybe they could have had a better word. But that would be undoing 30 years of Java, so we're stuck with it. Next yeah, it is kind of weird to be like, but next, isn't that there's current and then a next. I know. But next is just give me the next thing I would get if I wanted to get something from it. So the first time next is the first thing. That's why I always say, if you're in line and I'm at Starbucks and I say next, I get whoever is at the front. Yeah. All right, linked iterator. So for the linked iterator, all that needs is a reference to the current node. Because here's the thing too, you might be like, well, hold on. If you have only the current node, you'll lose reference to the head of the link structure. The iterator will, but the iterator doesn't need to keep track of the head of the link structure. It only needs to keep track of where it currently is. The bag, if this is, I'll go over here. I have a bag that has head. Right? So really these circles, this is my linked bag, right? Really these circles don't need to be within this object. They could be elsewhere, but where did it go? Oh, I expected to hear but I heard nothing and it freaked me out. All right, and then yeah. When I create an iterator, I'll have my little robot, which is some other object, and it keeps track of current. If I update current, head is still known by the bag. The iterator only cares about what's the next thing. Yeah?
Is the iterator typically a nested class inside of?
Yeah, it can be. It doesn't have to be. Often it is an internal one. But good question. Very good question. I can't even remember if I made them nested in mine or not. We'll find out, I think, soon. Well, here. Let's have a look. Topics. No, this is the wrong. Let's not have a look right now. I had the wrong project open. It's just too much of it to do. They could be. They don't have to be. Maybe it's good. Maybe it's not. Design decisions. All right. Constructor sets the current node to reference the head because it starts at the beginning. Again, assuming we want to go front to back. Checks if the current next has, has next does well, is there another thing? Is current null? If it is, there's no more. If it's not, yeah, there's another one. Then return the element. Next would be return the element and then update the reference that current has. Just like the array iterator, the iterator only goes in one direction. Once an element is retrieved with next, it's not possible to get it again unless you make another new iterator to start over. If the node class is an internal class, then the linked iterator will need to be an internal one. Oh, look, there we go. Yes, yes, good. This is actually very important. If the node class, now in my project structure, I have like a node that's actually an external one to show you for demonstration purposes, but within the, like the linked bag or linked stack, I used internal nodes. In order for the iterator class to know about an internal class, it must too also be an internal class. Otherwise, it would be like, it would look at like the higher namespace. That internal class is only known within the linked one, and the iterator would be like, where's the node? So in this particular case, it would need to be, but the array iterator wouldn't actually fall into this little conundrum because there's no an internal class there. You had a
So if the node isn't internal, the linked iterator still can be the linked.
It can be. It doesn't have, as long as it can know what a node is. Yeah. So that very good observation. Yeah. You had a question too?
Would it reference the, like, if the linked iterator was outside the class, would it reference that, the node method, or would it reference like a name?
I'm not clear on what you mean. Like if there was a namespace, like if there was like a naming conflict with an internal class and an external class, I don't even, first of all, don't do that. I don't even know if you can do that. That's why I think I called mine like singly linked node or something like that, or like linear node. I can't remember. Maybe you can do that, and it's smart enough. Either way, don't do that. Never introduce ambiguity and be like, it'll figure it out. Maybe. My assumption is if it was external, if you did, now we're playing a really big hypothetical. If you had, let me draw what you mean. For everyone that's scratching their head, right now we are wasting our time, but we're going to answer it anyways. So if you're scratching your head and you're like, do I need to know this? No. But what I would guess would happen, which might be entirely wrong because I don't really know what's going on and I'm too lazy to check right now. If I had a class here called like linked Q, and you had a node class within it, and you had a node class outside of it, and you had an iterator here, this is what you're asking?
Kind of.
So my guess would be like this one. If it was outside, it would go here. If it was inside, it would know to look here. And it wouldn't, I think.
Access the node inside.
What?
Inside the linked key.
The one outside?
Well,
No, I don't think.
I don't know. Let's not do this because see how it's ambiguous and we're left going like, what would it do? Yeah, now we're just playing a big what if, and there'll be an answer on what it actually does, but let's avoid that problem to begin with. Fun question though. It is a fun question. Again, for those of you, what? Don't worry. We were playing. All right, so collection iterators. So consider a sorted bag. If using an array sorted bag implementation, the iterator method that we have to write because we said our array sorted bag implements iterable or extends iterable, whatever keyword we needed. I must have a method called iterator that takes no arguments but returns an iterator. So for the array, I would return, well, an array iterator. I would give it the array bag and its size, because that's what that needed. A linked iterator, the linked bag would return a linked iterator. Remember, a linked iterator is an iterator. It is, so this is entirely fine. Since both versions of the sorted bag return an iterator, when you look at this, which bag do I have? Do I have a linked or an array bag? You don't know. You can't know, and that's the point. I don't want to know. I don't need to know. I don't care. I can iterate over this thing the exact same way, whether my bag is an array bag or a linked bag. It doesn't matter to me. I loop over it the same way. This is what we want. This is another really nice design feature that we get. This is really good. We like this. It generalizes our code. I iterate over it the same way, either way. Now, you might remember that when we had an array stack or a linked stack, an array queue or a linked queue, when we wrote the two strings, because we iterated over the underlying collections different ways, we had to write code to iterate over those underlying collections different ways. If it was an array stack, we used a for loop. If it was a linked stack, we used a while loop. Right? You remember this? Well, now you look at, this is how I would do it. I would say, remember, this is within the same, this would be like within the bag, like an array sorted bag or a linked sorted bag, right? And that method, that class has an iterator. So I can get the iterator for that collection and then iterate over it like this. Now again, you look at this. You have no way to know if this is an array or a linked implementation, and that's exactly the point. I don't need to write a loop for one that's different way than the other. I loop, it's the exact same. My toString for the two collections will happen the same way. This code will be identical, where before I needed it to be, well, here's one for an array, here's one for a linked. Look at that. If that doesn't get you excited, I don't know what else will. That's beautiful. This is a fantastic example of abstraction. I don't care. Give me the next thing. Is there another one? Give me the next thing. I don't care if I have to increment I, current equals current dot, now, I don't care. Now, that's focusing on the iterator. That little robot where I say, is there another one? Give it to me. Is there another one? Give it to me. That's the little robot's magic. Now, we are going to say, okay, we define a class to be iterable. I already talked about this. If a class is iterable, all it means is that it has a method. Come on, where is it? Yeah, all it means is it has a method called iterator that returns an iterator. That's all it means. If I say my class is iterable, it must have a method implemented called this. In the same way that if I say my class implements a stack, I must have all the necessary methods. Iterable only needs one, this one. It must return an iterator, presumably for that class. All right, so the iterator interface is used for creating an iterator object to iterate over something. If making a class that is to be iterated over, we could say, make the class implement iterable. For example, asking the collection for an iterator. So this is used when we ask a collection for the for its iterator, like we just saw, right? My bag, give me your iterator. The only method we need to implement is this one, like iterator. It returns an iterator, okay? So this will give me a reference to a little robot for that object. You will notice that in the examples we've seen so far, I am like outside of the class my bag. I'm in my main method, and I have a reference to a bag called my bag, and I say, give me the iterator. So now within my main method, I have reference to this little object. I can be like, okay, give me each thing. But we also saw examples, like in the toString, where I can get reference to an iterator from within the class, right? This is a method inside the bag class. Entirely fine. It's just a robot that helps me iterate over this collection. So within the iterable interface, there's one abstract method, iterator. We got to implement it. If we implement it correctly, that tells Java that I guarantee I can get an iterator object for this collection, which is great. So if we have a class that is iterable, it allows us to use what we call enhanced for loops, which these are those like Python style for loops, where you say for something in a collection of things, right? Remember how in Python you'd be like, for each character in my list, right? Hey, a list is iterable. for each character in my string. A string is iterable, right? Give me each thing in a collection of things. That's what this is saying. The only difference here is the syntax. Parentheses for Java, didn't need them in Python. In Python, you didn't use a colon, you wrote in, right? Thing in collection of things. And because it's Java, we need to specify the type of the thing, right? So this is an object that already exists, an iterable thing like a bag. It already exists, so it's a reference to some bag. And then we're saying for each, like, if we have a sorted bag of integers, I would say for each integer x in my bag. So this is like creating the variable with the type, but this already exists, right? Yeah.
So could you have for like a general sort of type where like the type of the reference variable is t?
Depending on where you would use it. If we go and we look at, I think, pardon me for a moment. So like, yes, so hold that thought, right? In this particular case, I know what it's going to be, right? I know what it's going to be because I created a sorted bag reference variable with integers in it. So if I'm like in my main method, right? Let's say I made a my bag. It's a sorted array sorted bag, a linked sorted bag. I don't care. It's a reference variable to my bag, which is a sorted bag of some type with integers in it. So if I want to iterate over it, I could say integer x in the reference variable to the thing I want to iterate over. Whatever this is a reference variable to, it must have an iterator method. It must implement iterable. If it does, I can do this. This is valid syntax. If it doesn't, and you're like, but I implemented it anyway, but you just didn't explicitly write implements iterator, Java doesn't trust you. You need to explicitly implement iterable. Well, I think I mixed those up there, but a class is iterable, and iterator is just that little sad or happy robot. So there we go. This is the look, we can iterate over it this way. Now, this is the same, like, by having an iterator, I can say, hey, iterator, do you have next? Give me the next. Do you have next? Give me the next. But if I have a whole collection that's iterable, I can do this. All right? I think I show an example of, yes. So right now, this is effectively like the exact same thing. I'm just doing it in a different way. The syntax is different, but I'm achieving the same thing. This is a collection that's iterable. Because it is, I can use an enhanced for loop just like this. Now, we know my bag is iterable because we wrote it, and it is. But I can get the iterator object and say, hey, iterator, do you have next? Give me the next. The exact same thing. This effectively, as far as like the compiler's concerned, like what it turns the code to and what it means is exactly the same thing. Okay? This is just different syntax for the exact same functionality. We're just doing it different ways. This is asking an iterator explicitly, being like, hey, this is Java does it for you because it knows it's iterable. So it knows if it's iterable, it returns an iterator. And if it returns an iterator, it can do this for you automatically because it knows it's there. That's why. Now, we can revisit the two-string example again. I showed you this one where we say, hey, iterator, do you have next? If you do, give me the next, do your thing, whatever. But we can revisit it again and make it even like more succinct. But this is a little funny, but it's not. Because remember, here, my bag is a reference variable to something that is iterable. If I'm defining a two-string method for an array sorted bag, which is iterable, this is a reference to an iterable thing. Why? Well, because I said at the top of the class that this is written in, it's iterable. Meaning this is an iterable collection. It's a reference to itself. What is that? Well, it's a reference to an array sorted bag. Oh, an array sorted bag is iterable. This can be weird, but it's probably less weird than you think. This would be like saying my bag, which is a reference to this object. And then within every object, there's like this like secret field, which is a reference to itself, right? When I say my bag, what is it? Oh, it's an array sorted bag, which is iterable. When I say this, what is it? Oh, it's an array sorted bag, which is iterable. Same idea. So the enhanced for loop at the end of the day, though, is like what I just said. It's just that syntactic sugar. Remember that fancy word, which just, it's a weird phrase, but programmers use it. It's just syntax that like means the same thing, but it's just a little nicer. That's all. Yeah.
I'm not quite yet convinced that it's 100% identical. So let's say we had, can you scroll back up? So let's say we had a bag that had A, B, and C in it. The toString here would give A, comma, B, comma, C, comma. But if you scroll back up to the other one, as soon as line 5 runs, the iterator no longer has a next anymore, so that comma wouldn't go at the end, would it? Because the while loop would collapse. So you'd only get A, comma, B, comma, C.
But here, you would get A. No, it would still be the same because it doesn't check if it.
It only checks at the beginning.
It only checks at the beginning. So it gets it, and at the last time, it gets like the C.
Yeah.
It's got the C. Next will get updated.
Yeah, but it doesn't know.
It adds the comma. Then it goes, is there next? No, and it stops. Good question, though. It's always fun to kind of think about those edge cases. Uh-oh, phone call. Suspected spam. Screen call. I love, like, this person you're reaching is using a screening. Oh, they hang up. Rats. I know. Lately, it's been mostly Scotiabank. And I'm like, why are you calling me? I don't use you. They're like, and I say, well, stop calling. Like, well, we could put you on a do not call list for 3 years. I'm like, how about you just stop it forever? And they're like, we can't do that. I'm like, why? Isn't that like illegal? Maybe it's not. I don't know. It should be. Stop calling me.
I don't think it's illegal to just call someone. But
And when a business is doing it, trying to solicit things, there might be different rules than just you doing it. Curses. All right, rant over. Anyways, point being, this is just syntactic sugar. But look, this is even like, look, if you're like, really, is that syntax any better than this? Maybe it's not, but I don't know. It's kind of nice, right? Those enhanced for loops, like a for each thing in a collection of things. Yeah. So now, because it's iterable, I can do it like that, right? An array itself is iterable, by the way. So you can use an array as is, like this. But be warned, like I've warned you before, if I said iterate over this array, using the built-in array, the built-in iterator that the basic array that you use has, it would go all the way to the end, including these things which don't exist. The one that we're writing is specific for the collection that the array is being used for. Okay? Yeah?
So you said earlier you could have an iterator that either went like forwards or backwards. Could you have both
Yes.
at the same time?
Yes, but this one, when you do it like this, it's going to call, so if you do, you would have iterator, and then you would have like reverse iterator. But you would have like the default iterator. So when you use it, the one that you want to get called by default would be like, when you do it like this, it would be whichever one you get when calling it like this. But if you went out of your way to be like, okay, I define my iterator method that returns an iterator. Then I can define another one called like reverse iterator that returns an iterator. The one that all the built-in Java crap is going to call is going to be the base one. So you're like, what if I want more control? Well, there's the default behavior, but then you can define your own iterators however you want. And we will see an example of exactly that once we hit the trees. Because you might remember earlier in the semester when we had linear collections and I said, what's the next thing? There's an obvious answer. When we have a tree and I say, what's the next thing? It's like, we have choices to make. And so we will actually generate different iterators for the various cases because maybe it really does depend on the order that we want. So great question, but we'll get there. All right, two-string, iterable interface, yeah, for each, cool, yeah. It's just, this is just syntactic sugar, right? If I want the iterator, cool, great, I can interact with the iterator directly, or I can even take a further step back and not interact with the iterator directly and just have Java deal with it for me through the enhanced for loop, which is arguably nice. Now, we actually had a giant deficiency in our code before for our equals methods. If I had a stack and another stack, and I want to know they're equal, I couldn't do it before. I could check if two array stacks were equal. I could check if two link stacks were equal, but I could never check if an array stack and a link stack were equal. The underlying container should have nothing to do with if these things are equal or not. If I have two stacks where the elements are exactly the same in order, they should be equal if they're equal, regardless if one's a linked or an array. We couldn't do that before because when we checked equality, we needed to iterate over the collection, the container. And if it was an array, we'd have to do it one way. If it was a linked, we'd have to do it another way. And if we tried to iterate over a linked stack, like it was an array, it wouldn't work. But now that we have a common way to iterate over anything, regardless of what it is, I can now check equality. I can now actually correctly check equality on those stacks or queues. Okay? Which is really cool. So, we can now, what do I have here? So consider equals from, yes. So these are what the equals looked like before. Here's the equals for the array one. Here I didn't even iterate over the array. I just asked the arrays equals thing. Right? Hey, does this array equal that array? This stack and that stack? Well, what if that was a reference to a linked stack which doesn't have an array? You can't do that. That's inadmissible. Here's the linked one, right? We use the general, typical iterate over a linked structure. But again, there's no this dot next in an array. That's not a thing. You can never check equality of these two stacks, even though they might be exactly the same. As far as Java is concerned, based on how we were doing it, they couldn't be the same. But now we can. Now, so first of all, notice here, I check that, oh, is it an array stack? I can only ever compare array stacks to array stacks. Here, I can only ever compare linked stacks to linked stacks. But when we go down here, okay, let me read this first. I want to make sure I don't miss anything. It should be possible to check equality on stack objects regardless of their implementation. However, with the current implementation, we can't. A solution is to use the iterable, take advantage of that iterable and iterator stuff. Okay. So now, I don't care. In fact, this could be an array. Like, when you're looking at this equals, look. You look at this equals, and you're like, okay, that's in the array stack, obviously, because 1, it says right there, and 2, we're checking if arrays are equal. This one's clearly in the linked stack because it says right there, and we have nodes, and obviously it's a linked stack. You look at this, you don't know. You can't know. Which is the point. So, you have a question?
Does instance of check if it increments stack?
Instance of, it just checks the type hierarchy, I'm guessing, right? So, instance of a stack. An array stack, it is a stack, so it's okay. Is that what you mean? Yeah. So what this checks is, okay, are they the same thing? Is O null? Is O not a stack? It doesn't check if it's an array stack. It doesn't check if it's a linked stack. It just checks, is it a stack? And if it is, it's a stack. Now remember, we use that fancy question mark thing because the types don't necessarily need to be the same to check equality. At this stage, I'm just checking, hey, I'm just checking, hey, is this a stack? If it's not, they're not the same. I'm going to worry about whether or not the underlying objects in the collection are equal. By the way, it's possible to check equality on things that are different type. Take the integer 7 and the number 7.0. They are equal. but their types are different. So it's not as simple as just like, well, the types have to be the same. They don't necessarily need to be. Case in point, an array stack and a link stack. The types don't need to be the same for them to be equal. So the question mark is doing a lot of heavy lifting here. It just means like, okay, the underlying types, I don't really care what they are now. I'm going to check their equality later. But at this point, we're checking, are they both stacks? And if they are, okay, are their sizes the same? If not, okay, they're not equal. And if they are, now you'll notice here, we're not making use of the iterable feature. We're not making use of the enhanced for loop. That's because we need to make sure we're iterating over in like synchronization of like the this and that iterator. Give me the next things, give me the next things. Where if you use an enhanced for loop, that'll only ever iterate over one. We need them to be moving synchronized. So now here I'm saying this iterator, that iterator. I could, maybe I should, say if this iterator has next and that iterator has next. Maybe I should say that here. It's not necessary because if they have the same size, they must, like I'll never get out of sync if they have the same size. But maybe I should say this and that iterator has next because you know how I feel always about like how intentional I make my code. So maybe I should there, I don't know, but it's something to talk about. Is my point clear here? If they both have 7 things, if I synchronize saying next 7 times, they're going to be in sync. And if you say, well, what if one has 8 and the other one has 7? Well, then we would never have gotten here because this would have failed. This and that sizes aren't the same. So yeah, maybe I should have done both, but whatever. And then okay, if objects equals this is next and that's next, if they're not equal, then we're not equal. We're done. If they are equal, check the next pair. Check the next pair, right? And there we go, right? Now you might also say, you never said get next down. Well, yeah, because I'm using it in here. When I call the next, it automatically moves these 2 iterators down to the next 2 as we go. But the point I'm making here is you look at this. I can copy and paste this code. It will be the same whether it's in a linked or an array stack. It's the same. Now I can actually check equality correctly. Before, we were cheesing it. We weren't really. We had no way to check if a linked or an array stack were equal. They should be, but we didn't have that power because we were limited by, well, we have to iterate over these things different ways. But by using this new little tool that does the iterating for us and adding a level of abstraction where I just iterate the same way regardless of the underlying collection, I can now do that, which is huge. Any questions about this? This is really cool stuff. Now, this is an example of something Java does, and a lot of programming languages do, about like how it leverages abstraction in a clever way to make our code and our design nice and consistent and clear. It's not something that's like necessarily like hardcore underlying what's the computer science. This is a design thing, but it's still obviously very important. Any last questions? Everyone's happy? Wonderful. All right, I'll see you all later.